So this lesson we're going to look at solving equations, or systems of equations, with 3 equations and 3 unknowns. So up until now it's been 2 equations and 2 unknowns. We did things like graphing, substitution, elimination. This time we're going to use algebra and we're going to solve for 3 unknowns. And so we're going to use all of those skills that we learned before. All right. So what we want to do is we want to first get one of the variables all by itself and isolated, and then hopefully we can solve from there. So what I see right away is I see that x is 2y. And so what I'm going to do is I'm going to take that third equation and I'm going to plug 2y in for x. So I'm just going to rewrite this third equation as 2y plus y plus z equals 11. So now what I did was I took that first equation, plugged it into the third, and now I only have 2 variables. And so my goal is to get down to just one variable, and then, or one unknown, I guess is what it's technically called. And then we can solve for that one unknown, and then we start plugging stuff back in and figure out the other unknowns. So now what I'm going to do is I notice that y is 2z minus 8. Well, before I do that, I'm actually going to combine 2y plus y is 3y. So 3y plus z is 11. But now what I was getting at was saying that we know that y is 2z minus 8. And so if I replace that y, it'd be 3 times y plus z equals 11. And that is 2z minus 8. So what I can do is distribute that 3 in, and I've got 6z minus 24 plus z equals 11. Combine like terms, I've got 6z and 1z, that is 7z minus 24 equals 11. We're going to add 24 to both sides. We get 7z equals 35. Divide by 7, and we get, we'll scroll up here, z equals 5. So we got one of our 3 variables, or one of our 3 unknowns. Z is 5. Now we have to go back and figure out what are the other ones. So just to recap, what we did was we started with, we wrote down the third equation, and I plugged in, so my first step was to plug in x equals 2y in for x, so we put 2y in for x, and then we replaced y with 2z minus 8. So this was just straight up substitution is what we did on this problem. All right, now that we know that z is 5, what I can do is I can plug that in to the second equation, y equals 2z minus 8. And so if z is 5, it's going to be 2 times 5 minus 8. So that'd be 10 minus 8, which is 2. So y is 2. And then, if I want to figure out what x is, I can use that first equation. So x equals 2y. We know y is 2, so it would be 2 times 2, so x is 4. So once again, the whole goal of what we're trying to do here is we're trying to solve, for x, y, and z, or the 3 unknowns. But the way we do that is we try to eliminate variables as we go and then get it down to just one variable. So let's look at example 2. We've got 3 examples for these. And example 2, we're not going to be using substitution. We're actually going to be using elimination. And here's why. If you notice, on each of these y values, it's either 2y or negative 2y. So what we're going to try to do is get rid of those y's and then solve for either x or z. But as I'm saying that, I'm noticing if I get rid of the y's in the second and third equation, look what is also going to happen. Those z's are also going to cancel out because those are opposite. So let's write this down and I'll kind of show you what I mean. We've got 3x plus 2y plus 4z equals 29. And then we have 5x minus 2y minus 4z equals negative 31. And if you notice here, if we add these two equations together, the y's are going to cancel out and the z's are going to cancel out. So that actually worked out kind of nicely. And so then what we're left with is negative 3x plus 5x is 2x. And 29 minus 31 is negative 2. I'm going to divide both sides by 2, and I get x equals negative 1. All right, so that worked out kind of nicely. We got x is negative 1, so x is already down. But we're still going to have to do a little bit of algebra to figure out y and z. So one thing that I'll do oftentimes is I will label these three equations. I'll label them A, B, and C, just to kind of make it so that I can kind of organize things a little bit. So what I did here was this one was B plus C. And when I did B plus C, y's and z's canceled out, and I was just left with x. So now what I'm going to do is I'm going to do A plus B. And you might be saying, why are you doing A plus B? Why is that advantageous? Well, if you notice with A plus B, I'm going to eliminate the y's. Those are going to be gone. So now we're just left with x's and z's. And guess what? We already know what x is. But hey, hold on a second. I'm also noticing, so this one I didn't analyze very closely at first. I'm also noticing that I'm going to cancel out the x's when I do A plus B. So there, we're going to be able to figure out z. So this one's actually falling into place really nicely. Let's write down A plus B. We've got 3x minus 2y plus z equals negative 14. And then negative 3x plus 2y plus 4z equals 29. So when I add these two equations together, I'm going to cancel out the x's, cancel out the y's, and we have 5z equals 15. Divide both sides by 5, we get z equals 3. So then the only thing that is remaining on here is what is y. And so if I pick any of these three, I'm going to choose the first one, just kind of arbitrarily. It doesn't really matter which one you choose though. And I'm going to plug in negative 1 for x, I'm going to plug in 3 for z, and then hopefully figure out what y would equal. So this is equation A again, and I'm doing 3 times negative 1 minus 2y plus z, which is 3, equals negative 14. This is negative 3 minus 2y plus 3 equals negative 14. Well, negative 3 and positive 3 are inverses of one another, so we end up with negative 2y equals negative 14. Divide both sides by negative 2, and we get y equals 7. All right, so once again, the way we tackle these types of problems is we try to eliminate variables as best we can, solve for one of those unknowns, plug it in, solve for the other unknown, plug those two in, you got your 3 answers. All right, example 3 is going to be a little bit more challenging than the first two. It's not going to quite as nicely cancel out, but we'll make it work, right? So what I'm going to do is we're going to either get rid of either the x's or the z's. So what I'm noticing is I have 2x, x, and negative 2x. That's kind of nice. We can cancel out some stuff there. I'm also noticing negative z, z, and positive 2z. That might also work. Really, it does not matter which way you choose to go. So I'm going to get rid of the z's first. But like I said, it truly doesn't matter. So let's do this. I'm going to label these A, B, and C again so we can all kind of make sure we're on the same page. And if I do A plus B, I'm going to write that down. 2x plus 3y minus z equals 3. And then x minus 4y plus z equals negative 38. So if I add these two together, the minus z and plus z are going to cancel out. And we are left with 3x minus 1y equals negative 35. So this is our new equation with x's and y's. And what I'm going to do is I'm just going to call that equation D. So I added a and b together, got rid of the z, and now we're left with an equation that has just x's and y's together. So I already used a and b. I'm not going to use a and b together again, but I do want to use a with c or b with c. We'll see which one makes the most sense. So if we look back at these, this is negative z, and that's plus 2z. Obviously, if we add these together now the way it is, those are not going to cancel out. And I want to cancel out z again so I can get a second equation with x and y in it. If I don't have a second equation with x and y, then I'm kind of spinning my wheels. So what I'm going to do next is I'm going to do 2a plus c. So if I double a, then I'll have negative 2z, and that'll be able to cancel out. So let's double a. That gives us 4x plus 6y minus 2z equals 6. So I just doubled everything in that equation. And then c, I'm just going to leave it alone. I'm not going to do anything to it. So negative 2x plus y plus 2z equals 32. All right, so 4x minus 2x is 2x. 6y plus y is 7y. The z's cancel out. And 6 plus 32 is 38. So what we have here is we have another equation where we have x's and y's. And we have, and equals 38. So I'm going to call this one E. So now we're going to work with these two new equations, D and E. And I want to get rid of either the x or the y by doing some sort of elimination method here. We could also probably use substitution if we really wanted to. Either one would be fine. What I'm going to do is I notice that I have a negative y and a positive 7y. If I multiply this by 7, then I'll have negative 7y and positive 7y, and the y's will cancel out. So that's what I'm going to do. So my next thing I'm going to do is I'm going to do 7d plus e, and that should cancel out one more unknown. So let's multiply everything in d by 7. So we got 21x minus 7y equals negative 245. I just punched that into my calculator. So that's 7d, and then e, we're just going to write it down as is. That is 2x plus 7y equals 38. Now, if I add these two together, 21x plus 2x is 23x. The y's will cancel out, plus 7y minus 7y. And then negative 245 plus 38 would be negative 203. And then I'm going to divide both sides by 23. And what do I get for x? And as I type this in my calculator, I'm realizing this is negative 207. Didn't do my math right, so this is negative 9 for x. All right, so what we did was we started out by getting rid of z's, and we got two new equations where they didn't have a z. Then I used those two equations to get rid of y, and what I ended up with was an equation with x. I solved it for x, and now we have x is negative 9. So x equals negative 9. Now, what we can do is we can take this x equals negative 9, and we can plug it into one of these two equations, either D or E, and solve for y. So it looks like D might be easier. It's just smaller coefficients. I don't think it really matters which one you use. So we've got 3x minus y equals negative 35. X is negative 9, so it would be 3 times negative 9 minus y is negative 35. Negative 27 minus y equals negative 35. Add 27 to both sides. Negative y equals negative 8. Divide by negative 1, and we get y equals 8. All right, so now we have x, we have y. Y is 8. Let's figure out what z is going to be. So the way we're going to do that is we're going to plug it into either the original A, B, or C. And once again, it doesn't really matter. I'll just do A because, I don't know, it's the one that I picked. So that is going to be 2x plus 3y minus z equals 3. And we know that x is negative 9, so it's going to be 2 times negative 9. Y is 8, so 3 times 8 minus z equals 3. We've got negative 18 plus 24 minus z equals 3. Negative 18 plus 24 is positive 6. Let's subtract 6 from both sides. We get negative z is negative 3. Divide by negative 1, z is 3. All right, so the moral of the story on all of these is take two equations, eliminate one of the variables, take two other equations, eliminate that same variable. In this case, we got rid of z. And now you have two new equations that have only two unknowns. Once you have that, then you get rid of one of those unknowns and you solve, and then you start plugging back in. All right, so a lot of stuff to take in, but this is all very, very doable if you understand how elimination and substitution work.